মোবাইলটা পড়ে যাবে।
তুই রাখ না, দূরে বসে একটা জায়গায় রাখ, অনার্স হয়ে যাবে, রাখ বলছি রাখ।
এটা কী করে হবে ভাই?
দেখতে পাচ্ছিস
উপরটা স্ক্রিনটা উপরে চলে
ঠিক
গেছে।
আছে, স্ক্রিন চলে যাবে, কী করার আছে? এখানে স্ট্যান্ড এইটা আমি কি বলবো স্যার, এটা নাড়াবেন না, এটা একবার নাড়ালে হয়ে যাবে স্যার।
টোটাল নাম্বার অফ স্টুডেন্ট কোথায়? আমরা ততজনকেই দেবো আর বাকি এন্ট্রি দেবো না। ওকে, ঠিক আছে। অলরেডি 11:30 বেজে গেছে। ওকে, নাও so before we going to start the workshop, so basic fundamental of PCR. Today we discuss about the PCR, next day we discuss about the gel electrophoresis. I think last day of examination of third year, the pharmaceutical biotechnology, PCR may be in the syllabus. Know it, but today for the workshop purpose I demonstrate again. So polymerase chain reaction or PCR. One is the PCR means polymerase chain reaction. One is the polymerase, one enzyme that can increase or amplify the DNA sequence. Generally, in case of some disease, some molecular evolution, some other criminal cases, in that case we are using this PCR. So a small thread which can identify which DNA, in case of criminal or in case of molecular evolution, suppose a 1000 years back upon fossils, that fossils DNA can be identified. How to identify? Nobody can identify this is which type of fossil, but the PCR, because this DNA, we collect this fossil and fossils to collect some DNA, and this DNA to amplify bigger and bigger. So finally we can identify the which type of fossils. Or in case of some criminal cases, in that case, suppose you want to some blood sample or maybe some hair thread which is present in the place. In that place, we can identify, we can match with this particular DNA or amplify it, and finally it will be checked in the gel electrophoresis. So finally the case, the criminal can be identified. So the huge application of the PCR nowadays. So now just we can say about this, the PCR. Here the introduction, evolution of PCR, principle, instrumentation, reagent, primer, design, DNA polymerase and component of PCR, and PCR types and applications. Okay. So before we start the PCR, it is known to you what is the replication process, because in the PCR basically we are amplifying the DNA sequence. Just say for example, there are one sound, there are যেভাবে কথা বলছি, if I slowly sound it, so we cannot hear, there is a problem in that case also. So one sequence you cannot identify what are the mutation or what are the changes, but you can amplify it, you can easily identify the what are the mutation or what are the changes. Suppose in case of skin cancer, there is a one TT dimer due to UV light exposure. So that TT dimer can cause skin cancer, but initially you cannot identify the TT dimer is produced. Generally, in the base pair rule, AT, or is due to UV red exposure, there is TT dimer will be produced, and finally it will produce some multiple myeloma or skin cancer. That cancer you can identify initially by the PCR technology. In case of another PCR, in case of COVID also, all of you know it, the RT-PCR. The RT-PCR, polymerase reverse transcriptase enzyme that can be to produce in the RNA to DNA. That's the RT-PCR. This PCR message is not applicable for the COVID test or AIDS, especially the RNA that cannot be identified, but others case will be identified or PCR. So before that, we just idea about what is replication. Because replication is a process by which a copy of DNA, mother to daughter DNA. So this is the process. I think all of you know it. No discussion. If you know discussion, then I will go through the discussion. Basically, it's one of the DNA primase and one of the RNA primer. That's why the primer is one of the most important component of this primer. So DNA primase and another is the enzyme, the helicase enzymes. Helicase, these are the unwinding enzymes and DNA primase and DNA primer, which is the RNA primer which synthesis for new strand like leading strand or lagging strand. Or another enzyme is the DNA polymerase to increase the chain length or amplify the chain length. So ultimately to get the number of one DNA to another DNA or copy of DNA. This is called replication. So PCR, these are the PCR. Already we have discussed about this. The PCR is the polymerase chain reaction. It is the in vitro technique by which you can amplify the DNA sequence. Basically, main thing is the what is the defect of the genes, or we can amplify the genes. The basic technology. So exponential amplification. What is the amplification process? First is the template. The exponential. First on the template DNA, okay? This is the template DNA. First the DNA sequence, double-stranded DNA. After that the one cycle, it will be 2, okay? So another second cycle, 1, 2, 3, 4, okay? When I want to amplify the 2, double. So ultimately 2 and 4 copies, 2 to the power 2, 2 to the power 3, and in the 16, 32. So after cycle, after suppose 32, 40 cycle, within 1 to 2 hours, it will be gives a millions of DNA sequence. 2 to 30, 68 billion of it's a billion of copies will be formed. So finally you can identify the what are the problems or what are the changes in the due to some PCR. Okay, the evolution of PCR. So first one, the how to develop the PCR message and who is the first the Hargobind in the year 1971 described the replication of short segment of DNA. Short segment of DNA and primer and polymerase in vitro. Okay, good. Hargobind I think know it. Who is the Hargobind Khorana? He is a scientist. Where? Indian or American? Indian scientist. Hargobind Khorana. Then in the year 1976, isolation of DNA polymerase from Thermus aquaticus. DNA polymerase is good. And it's a heat stable. Generally, all enzymes are thermolabile. So in case of PCR, one enzyme is required, which is DNA polymerase, and only the Thermus aquaticus and on another enzyme organism which produce the thermostable enzymes. And in the year 1976, isolation of DNA polymerase from Thermus aquaticus. Next, the year in the 1983, the Kary-Mullis, which invented the PCR method. Just 1983. Next, in the year 1985, Mr. Cycler was invented. Now this was the machine name is total thermal cycler. So 1986, the purified the cat polymerase first used by the PCR, and then 1988, the Perkin-Elmer introduced the automated thermocycler. That's why the PCR machine is initially launched by the Perkin-Elmer. I mean, the machine construction of the University. This is Perkin-Elmer. But the main inventor is the Kary-Mullis, and he got Nobel Prize in the year 1993 for invention of PCR. So this is the short story or history of PCR. This is the basic principle of PCR. First of all, PCR consists of a series of 20 cycles on the one basis. The main things already Master told you. First one is the denaturation at the 90 to 95 degree centigrade temperature. Second step is the annealing process in the 52 degrees centigrade temperature, and third one is the extension part. This is the amplification part, the 72 degree temperature. Okay. So the initialization, this step is reaction for the 94 to 96. Generally, we are using the 92 degrees centigrade temperature in our machine, and before that, we initialize the machine 5 minutes before start for better uncoiling the DNA. Okay. So 30 seconds, just the 30 seconds, but before that you can start, already we were discussing the workshop, before that you can, machine will be started the 5 minutes before, then you can, then 30 minutes, 30 seconds for the several minutes or several minutes, steps usually only done in the very beginning for the PCR reaction. Next, the steps is important for activating the host started the polymerase. If we use such a polymerase and the denature your template DNA, the first DNA is called the template DNA, and another is called the complementary or daughter DNA. So if the template GC means guanosine and cytosine, it is the highest we need from the extra long initialization step, that means amplification step, and hitting association with the DNA polymerase complexity. First denaturation, first cycling in the event, hitting one reaction mixture on 94 to 96 for 30 minutes. And DNA melting of disrupting the hydrogen bond between the bases of the yield single strand DNA. This is the first step. First to DNA strand, double strand helical structure, that will be uncoiling the state chain. Then after that a new strand will be formed. Second step is the annealing step. In that case, you use some primer, that primer draw and to bind with the complementary base pair of the template strand. This is called annealing steps. And the reaction temperature is 52 to 65. Generally, standard temperature is the 52 degrees centigrade for 20 to 40 seconds. So only the time required and reagents. So the temperature in the steps needed to the low enough, that is the denature primer can be formed. That's why the Watson and King base pair rule of the template. So low temperature at 50 degrees centigrade, 52 degrees centigrade. In that case, the base pair, the primer, is a short segment of DNA that can be bind with the original template. That's what base. Suppose the base pair template DNA, I see it later on. So usually this perfect annealing temperature is few degree lower than the melting temperature of the primer. Few degree lower, that means initially the 92 degree, then the 52 degree. And during these steps, the polymerase will bind with the primer and template and DNA complex, although the polymerase will not start the reading until the temperature raise into the next step. So only for complexing complementary base pair, then after increase the temperature up to 70 degree, then the extension or amplification will start. So temperature depends on the polymerase used. If you have different pharmaceuticals or other polymerase, in that basis you can use the temperature. So TAC polymerase is the optimum temperature activity on the 75 to 80 degree, but in case of TAC polymerase, pharmaceuticals generally 72. And the DNA polymerase synthesize new strand and complementary to the DNA template strand. DNA template strand adding by the DNA D and TPS, and all deoxy nucleotides, 4 nucleotides. Okay. And extension time depend on the DNA polymerase used as well as the DNA fragments to amplify. And it is the temperature, the DNA polymerase 1000 base pair per minute. The 1000 base pairs, so a very small time is required. And in that case, they are increased and amplified. So the generally, these are the base template strands, the two strands, adding with the reaction tubes, that is all the primers and the thermal DNA polymerase, and finally the denaturation will happen, and finally they are growing up into the 5' to 3'. Always this question will come in the different examination. The which direction? 5', all times 5' to never to the 3 to 5 times 5' to 3'. Okay. So DNA 5' to 3'. These are the base template strands. One is the template, another template, and this is the primer. The first primer, which is recognized in the 50 centigrade. First require uncoiling. Then this is the extension, and finally the TAC polymerase extension, and finally the daughter DNA, a nascent DNA was produced. Okay. So what are the steps of involved for these steps? The denature of double strand DNA and annealing the primers to single strand DNA. This is the temperature, 30 seconds. then the temperature will be low. So this is the step for deinitialization. Next step for annealing these steps, and 50 joule for extension of primer. So finally you got your desirable. You can identify the 30 cycle or 40 cycle as per dependency. If you not identify, then again it will be number of cycle will be increased. So get the more and more amplified result. So ultimately you can identify this way deinitialization, annealing and extension. So cycle is repeat 20 to 40 times. I think that will be enough for identify the actual DNA sequence, and then you can match with the particular DNA. Suppose in case of DNA or RNA, different PCR, you use it, and then if the disease can be identified. If there is some criminal case, that can be identified, or DNA fingerprint paternity, they are also identified. So in that case, you can use it. So reagents and instrument required. So generally DNA templates containing the desired segment already in our lab patient DNA sequence, not collected, not prepared for the DNA template here, and declared already present here. And another is the primer, which is a very essential component for complementary base pair. And another DNA polymerase for extension, and we know it, the DNA polymerase which amplify this base pair. And the deoxyribonucleotide triphosphate, all the nucleotide abundant quantity, otherwise it will be a problem. Suppose the base pair, suppose your templates and sequence contain A, B, G, C on that basis. If you are on that complementary way, nucleotide is not present, there is a problem. So enough quantity of DIPPS must be added in the sample. Okay, this is the buffer. How to prepare a buffer, step by step discuss it in this lab. And the bivalent cation to increase the primer annealing process by the magnesium or manganese, and the covalent cation like potassium, and some additives or adjuvant which are used for better result. So thermal cycler, nowadays we are using this machine. We are not for go through the discuss with the other machine. We are using the next. That's why it is a thermal cycler, because cycling process by the temperature. That's why the name is changed in the thermal cycler, not the PCR. PCR for polymerase chain reaction. That's why the name is component changed by the thermal cycler. So earlier thermal cycler was designed and used by the cranial fragments for DNA polymerase 1, computer elements for modern PCR machine. So every day it will be changes. Any machine can be moderated day by day, and sophistication obviously needed. So on that basis we are using this machine. Okay? So these are the steps are involved for the PCR, and finally we got the result. Okay? So once DNA cell ultimately get the number of DNA fragments, so amplify. Okay? So how to, then you can, after PCR is complete, then it goes to the gel preparation. Their DNA sequence you can send into under not PCR, which is visible under gel preparation, gel, and then you can match with the parent DNA along with this DNA. So if you match it, then it suppose in case of AIDS patient, there is RNA, or in the HIV, in that case RNA. So HIV, or in case of human, any criminal case or other case, in that case, suppose in case of the accident, there is some body can be claimed by the some other people. 2 or 3% will claim that this body is our. So in that case, how to identify the root? And this body is gone. How to? DNA. They can identify that 3% can claim that this body is our relative. Okay. So then from these 3% collect the DNA sample and DNA detect of the patient, dead body. So finally match with this DNA with the 3%. যার সঙ্গে ম্যাচ করবে অবভিয়াসলি তার সেই রিলেটেশন বা ফাদার মাদার যার সঙ্গে ম্যাচ করবে তার সঙ্গে সেটা পসিবল only the PCR and gender. So finally you can get the actual result, which is the actual relative of this particular dead body. So it's just like a fingerprint or DNA fingerprint. Even in case of paternity case also, sometimes paternity problem, in that case also same, you can identify which is the actual father of this particular biological father of this particular child. Okay? So primer design, that is different. Say another tough job of primer design. But here is the ready-made primer is available as per based on the template DNA. But you can design, but in the practical basis you can design the primer. And primer design is another job. Some person or some body can what every time you can prepare the primer or you give us some sequence that way you can prepare the primer. তুমি বললে যে ফ্যানটা আমাকে এরকম ডিজাইন করে দেবে ডিজাইন দ্যাট ওয়ে ইউ ক্যান ডিজাইন এখানেও সেরকম যে একবার বেসড অন দ্য টেমপ্লেট দে ক্যান ডিজাইন দ্য প্রাইমার or other you can design the primer also or you can purchase some ready-made primer that you can purchase the primer. Primer is essential or primer is a nucleotide sequence around 18 to 26 base pair in the length of provide 3 hydroxyl group of generally 5 prime to 3 prime and attachment in the nucleotides. Okay, so not discuss elaborately, better time is required. And the primer length or bias that is the primer is the secondary structure and primer and melting temperature. Okay, this is mostly for the analytic temperature, the base and GC and GC clamp. Okay, so DNA polymerase already discussed. The DNA polymerase or tag DNA polymerase is the Thermus bacteria, Thermus aquaticus. It's a heat stable DNA polymerase. In case of Thermus cyclone, temperature 92. Can you imagine? In your body temperature 92 degrees centigrade. 92. Our body temperature 37. If you 92, you cannot survive your day. Around 50 degree, Fahrenheit, 98. Your temperature rise more than 106 or 8. Your enzyme system will be lost. And enzyme will be coagulated. So enzyme will not working. So ultimately death. So here the Thermus aquaticus 90 degrees is very stable. And if this organism is not available, you cannot work in the PCR machine. First of all, that's why first of all you can isolate the enzymes. Otherwise, this machine is useless. So optimal temperature, the components of PCR. These are the data in your laboratory. That's why types of PCR. I will skip this different types of PCR. Basically, these PCR used are different. DNA only PCR. So what are these? These are the basic application. What are the usefulness of this PCR machine? Number one, molecular ectobiology, molecular epidemiology, molecular ecology, and DNA fingerprint, classification of organisms, genotyping, and prenatal diagnosis also, and mutation screening. Suppose you know the case of skin cancer, Okay, so genotyping, prenatal diagnosis, mutation screening already in case of skin cancer I already told, and another mutation. Nowadays the cancer can be detected by the very early stage. The PCR can be identified, so the patient can be easily recover it, and genetic matching also, and detection of the pathogen also. Nowadays some pathogens which are not detecting by the biological sample, blood sample, then you can detect by the genetic types. Okay. Another sequence is the bioinformatics, genomic cloning, and genetic engineering, site direction, mutagens, and gene expression study. So these are the huge applications. I think one person in abroad, person know better. Okay. Pal madam. In abroad, one person every day working on only based on the PCR. They working only, their duty is to only handling the PCR or every day. And one person they are a jail dog, another person they are LIC. So this is the machine that can identify the huge so many areas. So one man is required or woman or candidate can require for their main function, regular function to handling the or to PCR, to run the PCR. আর কোনো কাজ করতে হবে আমাদের যখন লেকচার দিতে হয় এইসব করতে হয়, বাট অ্যাট দ্য সেই শুধু একটাই কাজ হচ্ছে প্রত্যেক দিন হসপিটালের স্যাম্পল কালেক্ট করছে, দে রান দ্য পিসিআর, হট দ্য ডিজিজ রিলেটেড অর নট, অর হট দ্য আইডেন্টিফাই দ্য ডিজিজ or any problem related this one. It's a huge application. I think this is the most huge application in abroad, especially. But nowadays in India also, different disease, different areas we are using the PCR application, PCR gene and LIG. Given some examples on the case of cystic fibrosis, another genetic disorder that can be identified by the PCR gene is the CTFR gene. This gene this particular gene you can identify by the if it is a cystic fibrosis or not. The CTFR gene you can identify by the PCR, then automatically confirm it is a cystic fibrosis. Now only the one disease can be genetically treated by the cystic fibrosis. The disease is the cystic fibrosis. Till now, all are so many disease, cancer to hypertension to blood sugar for gene transfer, but only the disease, the cystic fibrosis, which can treated by the gene therapy. Okay. Another is the human immunodeficiency virus that can be identified HIV. HIV is a virus. Human immunodeficiency virus or human immunovirus, and the disease name is AIDS, acquired immunodeficiency syndrome. Okay, so these are the process. So HIV test really one PCR with the primer that will only amplify the section of the viral DNA found in the infected individual. Actually, in case of AIDS, the AIDS which virus which genome, RNA or DNA? RNA. How to identify? Is in this PCR there is no identified by the AIDS patient. It will be identified by the RT-PCR. Even in case of COVID also, all the RNA virus, RNA produce DNA in the human. When it is introduced into the DNA, the reverse. Then just one okay. So this PCR. So thank you very much for your listening to the lecture.
PCR, sir, thank you very much. But PCR the quantitative to qualitative. I'm going to call it qualitative. HIV virus and HIV virus how to detect the HIV virus. So the quantitative kind of why you are saying quantitative? Quantitative তো definitely, but why not qualitative? আমি RNA দিচ্ছি না DNA দিচ্ছি বা RNA থেকে DNA দিচ্ছি, এটা কি quality determine করছে না? So through this PCR also you can convert an RNA to a DNA. That won't quantify how much gene is amplified, but you just see the single strand gets into a complementary double strand DNA, right? যেটা HIV ক্ষেত্রে আমরা। So that's more important. You have to think PCR two types. RT-PCR, one is reverse transcriptase PCR. That is a qualitative PCR. When you check the quality of the genomic product, right? Whether it's an RNA or you convert to the DNA, how much it is amplified, or it is amplified or not. You don't know how much. When you go to the real-time PCR, that is the quantitative PCR, where you